Hello, everyone. My name is Aarti Jha, and I work as a principal data scientist at Red Hat. And a little about me, I work on building a lot of AI solutions, especially to ensure, cost cutting and more efficiency in the internal workspace. So today I'm here to talk about the most common problem that we face whenever we are dealing with any AI application, and that's hallucination. It's when your AI application or your model makes things up that does not actually exist. In this talk today, we'll basically go through what is the reason for these hallucinations, how can you detect them, how can you actually prevent them in in the life cycle of your production application, right? Let's get started. So, it won't be wrong to say that AI has become an integral part of our life. Everything that we do, be it related to work or personal life, we're always using AI in some form or the other. For example, at work, you may have certain assistants that are helping you or code assistants that you're using in order to code. Whereas in personal work, I'm sure everyone present here is using ChatGPT, Perplexity, Claude, or some of the other tools to just help them in the daily work. Something like creating an itinerary for yourself. Well, I'll be honest, I use GPT almost every day and, in fact, treat it as my personal assistant. Basically, I throw questions and scenarios and situations to GPT and expect it to come up with the answer. And I'll be honest, most of the times I do believe everything that it says. But it's important to know that every time when AI sounds right, it actually isn't. Let's try and understand this with a very simple example. Let's say I am planning a trip abroad for 90 days or 3 months, and I want to make sure that I'm allowed to work while I'm out for these 90 days. And my company is adopting AI, and so they've built HR Assist. This is basically an assistant that's going to help us answer all the questions related to my company policies. I go ahead, I type in my question, asking if I'm allowed to work from abroad for 90 days or 3 months. My HR Assist is quick enough to come up with the answer. It says, yes, the company policy allows remote work internationally for 90 days. I'm surprised. One, because I received this answer in less than 30 seconds. I did not have to go through creating tickets or reaching out to a human HR in order to get all of these details, which would then take a couple of hours or days to get the response. And secondly, it's of course in my favor, so I'm really happy about it. I go ahead, make my plan, pack my things, and move abroad and start working from there. It's only then that I get to hear from the human HR who says that I am not allowed to work outside unless I've taken certain permissions. Now I have a major compliance breach and also some tax violation waiting for me. At this point, I'm completely frustrated, and more than that, won't be wrong to say that I don't trust AI anymore. Now, this is a hypothetical situation, could happen doesn't really happen in real. But imagine if something like this does happen at a scale that can have some very severe impacts or outcomes, what would you do? Let's go ahead and define what hallucinations are. Hallucination is when AI systems or applications generate answers or information that are factually incorrect, have no grounding, and are totally fabricated. But it's going to generate them with such confidence and fluency that you tend to believe and accept them as truth. But it's important to note that this is not just an assistant or a chatbot problem. Most of the times, we associate hallucination with just something that you would face in an assistant. While, of course, Assistant is the most common application or tool being used in most of the enterprises and also at personal level, and it becomes really easy to track and understand hallucination here. Other systems like search and knowledge might also face this. Sometimes your model might end up referencing multiple different search results, but still answering or creating an aggregated answer which does not match any of that. Or you may have a summarization or reporting going on. Now, in summarization, it may have certain sentence or a knowledge that was never present in your actual content. Similarly, in reporting, it might add certain numbers which is not true and not a part of your actual data. The last one is coding and debugging. I think this is something that's really trending these days, and a lot of developers and data scientists are using code assistants in order to generate their code. right? And sometimes it does end up creating APIs or functions that are not exactly supposed to be there. I'll give you a first-hand experience. I was basically stuck with a piece of code and used one of the assistants in order to get the answer for it. I was using an open source package, a library, and had a function that was creating the issue. Well, my model ended up adding an argument to it, stating that this would definitely resolve my issue. However, it was only when I ran that code I realized no such arguments exist at all. For me, it was a very small to and fro, just a bit time consuming, but I did understand that this was completely wrong. However, imagine if someone is presenting a report to some stakeholder or someone in the higher hierarchy and presenting certain wrong numbers without fact checking it. Imagine the outcome that would have. Now that we've seen what hallucinations are, it's important to know, why do these actually occur? We can categorize them into four different buckets, starting off with the very first one, and the most simplest yet the most obvious reason, which is the input or the prompt issues. Now, most of the times, people think that if you're using a very good large billion model and a very good reasoning model, this model would not need enough instructions and would be able to understand things on its own. However, that's not the case. A lot of times, incomplete or ambiguous prompts is the main reason why hallucination occurs. Sometimes you forget to add certain constraints that do this or don't do that, which can lead the model to rely on its own information. Also, missing context, especially in case of retrieval systems, could lead to this. The next one is the model behavior. Of course, the model that you choose becomes a very important parameter here. It could be overgeneralizing on the data it is using, it based on the temperature. It can have randomness in its generation. And of course, certain cases, for example, if you're summarizing a 100-page book, sometimes the long context may lead to degradation, wherein the model might end up forgetting or just missing the initial information and replacing it with something fabricated. The third one is related to model itself. Now, every time you use a model, the model has been trained on most of the public data set. However, it's restricted and the knowledge is outdated beyond that particular time. So, for example, if I'm asking a question about recent current events to a model that was trained up to 2024, it would just end up creating random answers unless I've provided it with certain external help. Also, asking any question that is not related to that particular application but totally out of scope may also lead to hallucinations. And finally, your system design choices also impacts this. Do you have a grounding? Are you able to evaluate it correctly? Or are you focusing more on fluency rather than accuracy? All of these play a very important role. Now that we know how hallucinations occur, let's also get into understanding how do we detect these hallucinations in our own system. Starting off with the very first one, which is evidence based hallucination detection. As you can tell by the name, here we are trying to get some evidence or source and check if it's supporting the answer that the model has produced. Let's understand this with a very simple example. Let's go back to the HR assist that I was initially talking about. Say I'm asking my HR assist if contractors are also covered in the medical insurance policy within the company. My model outputs saying that the policy was updated on March 2024 and all contractors are a part of it. This is what the model claims. However, I do have source evidence with me, which basically is a policy document present in either my docs, in my database, that tells me that the last revision was only in Jan 2023 and the coverage applies to full time employees only. Now, you can basically tell that the model has created output that's not at all similar or grounded by the source evidence. We go ahead to find an evidence match using certain similarity check. This could be using any embedding model or LLMS judge to come up with a score. A threshold is what we need to have. So, for example, I say anything less than or equal to 35% is hallucination. This would basically tell us that this particular case is a hallucination case, and that helps detecting these cases within our system. There are certain scenarios wherein you would not have source evidence or you don't have ground truth data at all. In such cases, you can use something like consistency based hallucination detection. Here, what you're trying to see is that your model is consistent throughout with the outputs or not. So, taking an example again, if I ask the question, what is the duration of notice period, to my model multiple times and get the answer that it has generated, the answer should be consistent throughout. Sometimes it might be same, similar, or completely different, just like this one. Here, as we can see that all three answers are different, basically pointing that the model is not consistent at all, and there's a good chance that this is hallucinating. We go ahead and find the semantic similarity to get the if it's logically consistent or not. Remember, we are not trying to do like a frequency match here, because there might be cases where one part would say 2 months while the other would say 60 days. So we don't want to go ahead with just frequency match. Once we have these different comparison numbers with us, that will again give us the agreement score as to how consistent is my model. Based on that, I can classify it as low, medium, or high. And finally, a low score means it's hallucinating. Similar to this, we have another way, which is the model confidence based hallucination. Previously, we were just trying to see if it's consistent by semantic similarity. In this case, we use the token probabilities in order to come up with the uh, metrics that we are looking into. For example, I have a user query or the question that I've asked. Based on that, the LLM is going to generate next tokens one by one. This happens using probabilities. So, for example, if these are the four tokens or the token vocab that I have in my LLM, it's going to have probability across all of these different tokens and select the one that has the highest. So, in this case, you can see that is has the highest. So, the token that's going to be selected is going to be is. Now, imagine if there was a situation where all of these four tokens had a very similar distribution, something like zero point 0.3, zero point 0.2. In that case, you would say that the model is not very certain about which one to select. There is a little uncertainty present. And that's exactly what we're trying to calculate here. We have certain uncertainty metrics defined for us. The first one is token entropy. This is basically just checking how spread out is the probability or during the generation. So based on these numbers, it's just going to calculate the entropy. The lower the entropy, the more certain the model is. The second one is probability drop. This is a way to detect if two consecutive tokens have a very high difference in the confidence score. So, for example, the first token had the probability of 0.91, but the next one drops down to zero point 0.3. In this case, there is a possibility that the model is not really sure what to have selected as the next token, and as a result, could lead to hallucinations. The last one is pretty similar to what we just did in the previous section, but instead of calculating semantic similarity on multiple runs, it checks for the token changes that happens within the answers. So, for example, if I run the same question again and again, and I see that this particular token changes every time, it does give me a hint that there is some sort of uncertainty. And as you can see, low uncertainty means that it is definitely stable and the output is confident, whereas the other way around is a potential hallucination risk. One thing to note here is that both of these metrics, that is methods, that is the consistency based and confidence based methods, are not really taking into account whether your answers are factually correct or not. If that is the requirement, we need to refer to the first method. These are only trying to tell you whether the output is stable and if the model is consistent with its answers over the period of asking the questions, right? Now that we know how to detect these hallucinations, next comes how to prevent them. So, preventing hallucinations is the most important part. Just knowing is not enough that your application is hallucinating. In this case, what we do is we have two different methods, basically at a high level, that can be used in order to overcome this hallucination problem. The first one is model and prompt level. So this is basically going to be talking about what are the prompt constraints that you could add, temperature changes, fine tuning, all of those details comes under model and prompt. At system level, everything around the model, how do you feed things to your model, would be accommodated. For example, grounding using tools or RAG systems and human in the loop. Let's go into these one by one and try to understand each of them. Starting off with the model and prompt level, The very first one is constraint prompts. Like I mentioned initially, that prompt is the most common cause of why hallucination occurs because there is a lack of enough instructions and certain constraints as well. As you can see here, what's important is to limit how the model is going to reason and react to the questions that are being asked. For example, if you have a RAG based system, all you have to do is mention that answer only using the provided context and do not use your own or general knowledge. Adding this one line is going to make sure that your model is restricted to the data being provided. Of course, if the retrieval isn't correct, that is going to impact your overall answers, but that is not going to be a hallucination problem. An extension to this is the refusal policies. While here we are telling the model not to answer anything that it's not fully aware or grounded with, here we let the model also decline or let the user know that I don't know the answer for this. So basically, imagine scenarios where we were not able to find any verified source, or the user ended up asking some totally different question. Let's say I go ahead and ask a finance related question to my HR assist. In that case, my model should be able to tell me that I don't know the answer for this or this is out of scope. So adding those additional instructions will also make sure that the model never goes to its own knowledge to answer such questions. The third one is low temperature. We've all, I'm sure, worked around with LLMs and know that temperature is what handles the creativity of the model or the randomness of the generated output. Having the temperature set as low as possible is going to make sure that your outputs are mostly stable and deterministic and kind of replicable. Finally comes the domain fine tuning. Well, of course, fine tuning is not the first choice for most of the applications that we build, but can definitely be proved to be a good way of getting rid of hallucinations. Because once your model is trained on your domain specific data, it will know exactly what to answer, even if it's not provided with any ground truth. Moving to the system level prevention. The first one is grounding. Now, grounding means that you have a single source of truth that needs to be referred to every time a question is being asked. You're forcing the model to only refer to this particular ground truth. For example, there might be cases wherein an internal database needs to be hit every time a question is asked, or an API has to be used in order to answer a particular question. An extension to this is the tool use. These days, LLMs support tool calls as well, and it's a very good example of in situations, for example, let's say I want to get the weather. Instead of relying on my LLM to do that, let's have an API that can do that for me. When fed with the appropriate city or state, it should be able to fetch that for me. Similarly, instead of asking the LLM or the model what is 2 plus 2, we can have a calculator tool that can do this for me. This makes sure that you're not relying on the model's knowledge, but providing it with external grounding data that can be used and will definitely be logical. The third and the most common one is RAG, or retrieval augmented generation, which is nothing but context injection. You're retrieving certain relevant information for the question asked or for the use case that you're serving, and provide that to the model so that it can use this in order to answer your questions. Now, it would have been really good if my HR assist in the beginning would have accessed the document, HR document policy before answering about the 90-day international travel. Also, it's important to note that just RAG alone is not going to solve the problem. Most of these different prevention mechanisms do not work well when used alone. They have to be done in combinations so that, let's say, RAG plus tool use plus prompt, these together might help minimize hallucination overall. The last one is human in the loop. This is a bit tricky, manual, and also it's expensive in terms of using a human always to get the answers validated. However, for scenarios that are really high risk, have high risk outputs, it's always better to have a human evaluating the final answers before it goes out, because hallucinations could then have really severe impact, especially at business level as well. What we have seen so far is what is hallucination, how do you detect them, and how do you prevent them. But most of this till now has been with the assumption of a controlled environment. Things change completely when we go live with production. So, let me give you a very brief case study. This is related to a task, an AI assistant basically, that I was building along with my team. Now, this AI assistant had access to multiple data sources and had multiple tools that it could access. And finally, based on the question that the user asked, it could go ahead and generate the answers. When we started with a demo in the initial days, it worked perfectly fine. So before the release, we were able to give clean curated queries and it passed offline accuracy tests. In fact, the tool call was also happening correctly. But things changed when this went live, when real users came into picture. The reason being that the real users don't ask clean questions. There are a lot of vague and messy questions being asked. The tools that are being called are sometimes not in the right order. And also, there could be half or partial retrieval of context, and the LLM could do the rest of the part by creating very confident answers. That's when we realized that it's very different to work in production versus in, say, a stage or a demo scenario. These errors that we saw were not because of a single error that has been caused. It is basically an accumulation of multiple errors across the layers that finally amplified to become the failure that we were looking into. So basically, tackling hallucinations is not just at prompt level, at model level, or even at a base limited to detection. It's basically a full system and life cycle level that you need to ensure this entire process. This brings me to the final part of how to build a trustworthy AI lifecycle. Starting off with data. Data plays the most important role when dealing with any of the large language models or any models for that matter. The first step is to have a
Hi, Aarti. I'm so sorry, but we would have to end this session. So sorry.
I'm almost on the last slide. Can I just complete in 2 minutes?
Because we have to start the next session. I'm so sorry.
Okay, all right. Thanks, everyone. I'll please feel free to ask me any questions. You can reach out to me on LinkedIn, and I can take your questions there. Thank you.